Okay, now let's look at those example questions. Okay, basically they ask me to sketch the inverse function of the well the the inverse graph of the given function. Okay, so uh, a simple way to sketch those graphs is to use the method uh, interchange x and y. Okay, so I show you how do we do that now. Okay, let's look at graph A first. Okay, in the graph, I have an asymptote at y equals to 2, but after I interchanged x and y, I will have an asymptote here at x equals to 2. X equals to 2. Okay. Okay. I think something wrong with this question. There, right? The y-intercept must be 3. Okay. Okay. Now we say an y-intercept at 3. So after interchange x and y, I would have an x-intercept at 3. Now I can just draw my graph very easily. So I should have something like that. Okay. Yeah, I should have something like that. And by the mean this is my inverse function, and the domain of my inverse function is the range of the original graph. So let's say the range of the original graph is from 2 to positive infinity. Okay, so my domain is x belongs to circle bracket 2 and infinity. Okay, yeah, it is very easy to draw the graph using interchange x and y method. Okay. Now let's say question B. In question B, I have a y-intercept at I have a y-intercept at 3. So similarly, I will have an x-intercept at 3. Okay. And I have a point there. Okay. In the original graph with minus 2 and 1. So in the new graph, in the inverse graph, the point should be 1 and minus 2. Okay, because if we interchanged x and y, so any point on the original graph should be any point of the original graph should interchange x coordinate and y coordinate. So in my inverse function, I would have this point. Okay. Now just let me draw the graph. It should look like that. Okay, and this is my inverse graph, and the domain of my inverse graph is the range of the original graph, which is from 1 to positive infinity. Okay, and well, we use a square bracket because this point is included. Okay. 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 Now let's look at this kind of examples. Okay. Say basically they ask me to find the intersection point between the function and its inverse function. Now let's find its inverse function first. So the original graph is y equals to x squared. The domain is x from including 0 to positive infinity, and the range, okay, if I draw this graph in my mind, the range is going to be y. It's a simple parabola. Okay. Y belongs to from 0 to positive infinity. Okay, so I rearrange. Okay, I have to interchange x and y for for inverse function. Okay, so I will have x equals to y squared. The range becomes 0 to infinity, and the domain is become square bracket 0 to infinity, and it will be y equals plus minus square root of x, and I have two functions, but because of the range there, okay, I only can have, well, my function will be y equals to positive square root of x, simply because the function minus square root of x would have a different range. So okay, and the domain will be this one, from 0 to positive infinity. So my inverse function, okay, is going to be square root of x, and the domain is going to be from 0 to infinity. Okay. Now I have the function of I have the equation of the function and the equation of the inverse function. Now I need to find the intersection points. Okay, to find the intersection points, we have to make them equal. So okay, to find intersection points, between two graphs, two functions actually. I have to make them equal to each other. Okay. Okay, for instance, if I want to find the intersection point between y1 equals to x and y2 equals to x, x cube, I just make them equal. So y1 equals to y2, then x equals to x cube. Then I solve the equation x squared equal to 0 and 1, and x is going to be positive and minus 1. So the graph y equals to x and y equals to yeah, also 0. Okay. Y equals to x cube would have 3 intersection points, there, there, and there. Okay. 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 However, in our equation, in our question, we have to make f(x) equals to the inverse function to find their intersection points. So I would have square root of x equals to x square, and to solve it, I would have x equals to x power 4. Okay, I square both part, and I would have 1. Okay, and I would have x power 4 minus x equals to 0, and I take x out, x cube minus 1 equals to 0, so x would be 0, and x cubic should be equals to 1, so x will be 1. So my the x coordinate of my intersection points will be x equals to 0 or 1. Okay, from here. Okay, so now what do I do is I have to substitute them into any equation to find the y-intercept, and the two coordinate will be 0, 0 and 1, 1. Okay. If I draw a graph, okay, if I draw a graph, it would be to show you. Okay. This graph should be my this graph should be my f(x), okay, and the inverse function graph should be something like this. Okay, and I have two intersection points there, okay, which is 0, 0 and 1, 1. Okay, okay. The important thing about finding the intersection points between any graphs is there may be more than one answer. So the two graphs may be intersecting each other more than one times. So keep that in mind. In this case, we have two answers. Okay, and also if you coming across to find the intersection points between a function and its inverse function, what's happened is we all know the inverse function is a reflection on the line y equals to x. Okay, so when we find so what's happened is when we find the x coordinate, we can just substitute this to the function y equals to x, and it's quite easier to find out what's the y coordinates of the intersection points, because it should lie on the line of y equals to x. Okay,